You build Gemini 2.5 Pro.
It crushes coding, math, reasoning soda on the hardest benchmarks.
You give it 3 hours of video.
It parses every frame, every nuance like a human watching intently.
You craft Gemini 2.5 Flash.
Same sharp reasoning, but sips compute, slashes latency.
You refine 2.0 Flash flashlight.
Lean, fast, cheap high performance without the bloat.
Alone. They're strong.
Together, they own the Pareto frontier.
Capability versus cost, they span every inch.
You test its multimodal muscle.
Feed a lecture video.
It spits out an interactive web app, quizzing students on the content.
Long context plus multimodal plus reasoning, a new agentic world unlocks.
You check safety, helpfulness.
Less sanctimony, fewer refusals.
Sharper at cybersecurity. ML R&D, no dangerous leaps, just smart strides.
Critics say prove it.
You show the jump from 1.5 Pro, 5x better on Aider Polyglot, 2x on SW Bench.
Educators pick it by a mile.
You realize.
It's not just a model family.
It's the bridge.
Between what AI could do.
And what it actually does.
For everyone, everywhere, at any cost point.
Well,
right.
Yeah.
Was that a technical briefing delivered by a highly caffeinated poet?
It certainly had that energy.
Because it just dropped some serious knowledge, like a lyrical data dump straight from an AI lab.
Indeed. It definitely sounds like the unvarnished, maybe slightly sleep-deprived perspective of someone who's spent the last year pushing the absolute limits of AI. A rather unique way to outline a project, I must say.
Unique but effective. And, you know, that intense opening perfectly sets the stage for today's deep dive. Think of that lyrical data dump as a lightning-fast preview because we're plunging into the world of advanced AI models, specifically this Gemini 2.5 family.
Right.
Our mission today is to unpack the remarkable capabilities these models bring, understand the practical implications, you know, what it means for users, and also explore some of the surprising challenges that pop up when AI gets this good.
Yeah, that's crucial.
We've got a stack of fresh reports, technical notes here. Almost as intense as that opening, frankly. It should fast-track you, the listener, to being really well-informed on this groundbreaking AI. So what does it all mean for us?
Well, what's immediately clear, even from that poetic intro, is that we're not talking about just one new model.
Right.
It's a whole suite. This Gemini 2.x family, as they call it, it's designed to offer a really broad spectrum of performance and efficiency options. It caters to vastly different needs.
That's a crucial distinction, isn't it? It's not one size fits all. It's more like a toolkit.
Exactly.
You've got Gemini 2.5 Pro, 2.5 Flash, and then the earlier ones, 2.0 Flash and Flashlight. It feels like they've engineered AI for, well, almost every possible use case, from super demanding research right down to everyday apps.
Precisely. And this concept is really central to understanding their strategy. They talk about spanning the full Pareto frontier of model capability versus cost.
Okay, the Pareto frontier. Bring that down a bit.
So basically, it means finding the optimal trade-offs. You want the best possible capability for a given amount of cost or computational resource. Instead of just one point, they're offering a whole curve of options.
Ah, I see.
This isn't just about offering more choices, it's a fundamental shift. It makes cutting-edge AI potentially accessible and practical for really diverse applications. Imagine being able to pick exactly the right balance of raw power and operational efficiency for your specific project.
Right. Whether you're building like a massive research system or just a quick, responsive consumer app.
Exactly. It sort of democratizes AI power for different budgets and needs.
Okay, so flexibility and efficiency are key. How does this family approach play out with their top model, Gemini 2.5 Pro? Our sources are definitely calling it the most capable model yet.
It absolutely is, based on the benchmarks. Gemini 2.5 Pro demonstrates what's called state-of-the-art performance. SOTA, you'll hear that a lot.
SOTA, right.
Particularly in frontier coding and reasoning benchmarks. The reports call it a step change in performance compared to its predecessor, Gemini 1.5 Pro.
A step change. Can we quantify that?
Yeah, they give some concrete numbers, which are pretty striking. In just 1 year, Gemini Pro showed a staggering 5-fold 5x improvement on the Aider Polyglot benchmark.
5 times.
And a 2-fold 2x improvement on SW Bench verified. These aren't trivial tests.
No kidding. 5 times better in coding, twice as good on complex software engineering tasks. Those aren't just academic scores, are they? That signals real-world problem-solving ability. Like fixing bugs, writing new code, understanding huge code bases.
That's the implication, yes. Real-world engineering prowess.
But does this kind of capability signal a shift? I mean, how will human developers work with this? Is it more like a co-pilot, or could it actually automate entire engineering tasks soon?
That's a fascinating question, and one the researchers themselves are clearly thinking about. The reports suggest, for now at least, it's more about enabling human ingenuity, not fully replacing it. Think powerful accelerators.
Okay. Augmentation, not replacement yet.
Precisely. And beyond just code and reasoning, 2.5 Pro also has really impressive multimodal understanding.
Multimodal meaning it handles different types of data.
Exactly. Text, images, and importantly, video. It can apparently process up to 3 hours of video content, parsing frames, nuances, connecting concepts across different sensory inputs.
3 hours of video. Okay, now let's connect that multimodal power because the sources describe an application here that sounds genuinely transformative. Tell us about the lecture example.
Ah, yes, that's a great illustration. Imagine this. The model takes a video of an entire lecture, say a 3-hour university class.
Okay.
And then just from that video, it creates an interactive web application designed to test a student's knowledge on that specific lecture's content.
Wait, so it's not just transcribing the audio?
No, far beyond that.
Yeah.
It's understanding the lecture content, figuring out the key concepts, the arguments, the examples, and then applying that understanding to build a functional quiz or learning tool.
That's incredible. It bridges understanding and creation.
It really showcases what they describe as new agentic workflows.
Agentic workflows. Okay, define that for us.
So, agentic problem solving refers to AI systems that can tackle complex, multi-step tasks more autonomously. Think of it less like a single question and answer and more like an AI project manager.
Interesting analogy.
It sets a goal, plans the necessary steps, executes them, and can even review its own work to achieve that larger objective, much like a human would approach a complex project.
So it's not just responding, it's acting over time to achieve something. That feels like a big leap in autonomy.
It is.
And what's really exciting is how quickly these Gemini 2.5 models are enabling some, well, pretty surprising agentic workflows. The sources mentioned one example that really caught my eye, something from an independent developer. Gemini plays Pokemon.
Yes, that project is a fantastic example. It really highlights the model's ability to handle incredibly complex interactive scenarios over long durations.
Playing Pokemon isn't simple button mashing, right? There's strategy, memory.
Exactly. It's not just pattern recognition. It's strategic navigation, decision-making in a dynamic environment, adapting to unexpected things, remembering what happened hours ago in the game, maintaining context across hours of gameplay.
So an AI not just playing, but strategically navigating it like a human, remembering, planning, frankly, probably playing better than I ever did.
Quite possibly. It's a huge leap in demonstrated AI autonomy. And the sources point out these capabilities aren't just for hobby projects. These models are already powering numerous Google products internally.
Makes sense. Now, another crucial aspect the reports emphasize is the user experience, safety, helpfulness. How does it actually feel to interact with these things?
That's a key improvement they're highlighting. Compared to Gemini 1.5, the 2.5 models are apparently much more helpful, and crucially, less likely to refuse to answer important user queries or respond with an overly sanctimonious tone.
The overly sanctimonious tone. Many users will appreciate that change.
Right. It signifies a more refined, more user-friendly interaction, moving away from some of those frustratingly overcautious refusals you sometimes got with earlier models.
That addresses a common concern, doesn't it? Making the interaction smoother, more collaborative. That seems vital for wider adoption.
Absolutely. And on the safety front, while the models did show notable increases in critical capabilities, these are areas like cybersecurity, advanced ML R&D, sensitive stuff. The report explicitly states that they have not crossed any critical capability levels. Think of these levels as predefined guardrails, significant milestones for AI development that, if crossed, would signal a really transformative, potentially risk-altering leap.
So, smarter in key areas, but still within established safety boundaries.
That seems to be the message. It indicates a continued, very intentional focus on responsible AI development, keeping these powerful capabilities within defined safety parameters.
That's incredibly reassuring, especially as these models get so powerful. But speaking of powerful, our sources reveal a critical and maybe slightly ironic challenge that's emerging. Evaluation, testing these things.
Yes, this is fascinating. As these models get smarter, measuring their progress becomes incredibly difficult.
How so?
Well, the problem is twofold. First, existing benchmarks are saturating quickly.
Meaning the AIs are acing the tests?
Pretty much. They get so good they max out the scores, which makes it hard to differentiate performance between top models or even track ongoing improvements in a single model. It's like asking a physics PhD to take a high school algebra test. You don't learn much about their actual limits.
So the AI is getting so smart, we're struggling to come up with smart enough tests for it. That's a major aha moment right there.
It really is. It's an arms race, not just in building AI, but in evaluating it.
And what's the second part of the problem?
It gets more complicated. Creating new benchmarks that are challenging enough is becoming more expensive and time-consuming.
How expensive are we talking?
The reports give a really striking detail. For one benchmark called Humanity's Last Exam, apparently, experts were paid up to $5,000 for each question accepted.
$5,000 for one test question.
Just to create a single question hard enough to truly push the boundaries of these advanced models.
Wow.
And now think about evaluating those agentic systems we talked about, the ones that tackle multi-step problems, use tools, critique themselves.
The complexity just explodes.
Exactly. You need benchmarks that can measure this multi-step reasoning, tool use, self-correction, evaluations that scale in difficulty, cover more capabilities, and somehow reflect economic value. It's a huge research challenge in itself.
That really underscores the immense effort involved. And it highlights something else our sources kept mentioning, that this isn't just a few geniuses in a lab.
Not at all.
The development of Gemini is described as a massive collaborative effort. Over 3,000 individuals across Google, apparently. Research, engineering, safety, operations, all working together.
It's truly a monumental collective effort. It takes that many minds, that much coordination, to even begin tackling the scale of these AI challenges responsibly.
So, wrapping things up a bit. We've seen how the Gemini 2.5 family isn't just about raw power, it's about this spectrum of optimized capabilities.
The Pareto frontier.
Right, pushing the boundaries of what AI could do, but also bridging it to what it actually does for, well, everyone, everywhere, at any cost play it, like the rap said at the start.
Yeah, this deep dive really showed us an AI that can, understand a complex lecture, build a web app from it, even play a strategic video game for hours. Impressive stuff.
Definitely.
But also pulls back the curtain on this fascinating new frontier in AI research itself. The sheer challenge of finding new ways to measure such rapidly advancing intelligence. The evaluation problem.
Which leaves us with a pretty important question for you, our listener. If creating effective tests for AI becomes just as complex, just as expensive as building the AI itself, what does that mean for how we understand, how we govern, and ultimately, how we trust the next generation of these intelligence systems?
Or perhaps looking ahead. Will the AIs themselves eventually need to help us design their own benchmarks, leading to a whole new kind of collaborative intelligence? Maybe. Something to think about.